If your retriever finds okay passages but ranks the best one at position 7, you need re-ranking. I'll show a simple second stage scorer that upgrades top K quality fast. You likely see reasonable candidates, but the best answer hides down the list. Re-ranking gives you a second opinion. It inspects query and candidate pairs more carefully and pushes true winners into the top 3. By the end, you will understand a tiny practical re-ranker and how to tune a couple of knobs to improve real search results. I'm Professor Pi, teaching AI engineering and LLM systems from basics to advanced with simple, concepts-first Python that helps you solve bigger real-world problems. We will build a lightweight 2-stage pipeline that starts with a cheap retriever and then applies a focused scorer to the top candidates. This keeps latency low and improves quality where it matters most. The code pieces are tiny and meant to teach the idea, not to be production ready. This snippet builds a minimal token overlap retriever and shows a weak top 3. It creates a simple candidate pool by matching query tokens to document tokens and ranking by raw overlap. The key idea is cheap recall first. The snippet reads a small corpus, tokenizes documents and the query, counts shared tokens, and returns the top 3 matches. That top 3 is intentionally noisy, so you can see the need for a second stage. The overlap score is a blunt instrument. It finds related text, but it does not understand term importance or phrase-level signals. And that weakness is exactly what the re-ranker will fix. Now we add stability to the candidate pool. This snippet adds simple IDF weighting to form a stable candidate pool. The code computes inverse document frequency to downweight common words, and then scores candidates by the sum of IDF values for overlapping tokens. That reduces the influence of stop words and raises rare but informative matches. Practically, this changes which documents enter the top pool, and you can treat the number of candidates as a tunable value called top K. If you increase top K, you get more candidates for re-ranking at the cost of more re-ranker work. If you lower it, you save compute but risk losing the best answer. This step creates a nicer input list for the cross-encoder style scoring that follows. Next, we score pairs rather than documents independently. This snippet re-ranks candidates using cross-encoder style pair features. The main idea is to compute features that depend on both the query and the document together, and then score that pair. In the mini version, we build a small feature vector per pair. Examples include IDF weighted overlap, the fraction of query tokens covered, and a simple position-aware hit count. These features capture interactions that single document scorers miss. The snippet computes the pair features for each candidate and then produces a scalar pair score with a lightweight function. This produces a reordered list that often promotes the truly relevant passage above generic matches. Next, we teach the re-ranker to prefer the right signals. This snippet learns simple weights from tiny labels to refine re-ranking. The snippet collects a handful of labeled pairs where you mark which candidate is better. It then fits a tiny linear model that maps the pair features to a relevance score. Because the feature set is small, you can train with very few labels and still get improvement. The code includes a regularization choice that prevents overfitting to this tiny dataset. Changing the amount of labels or the regularization strength directly affects how bold the re-ranker is. With a few good labels, you get a focused scorer that prefers precision over generic matching. Now we combine scores and prune weak candidates. This snippet filters weak docs and blends scores to boost final top 3. First, it removes documents whose re-ranker score falls below a threshold, treating them as unlikely answers. Then it combines the original retriever score and the learned re-ranker score with a blend weight. The blend weight controls how much to trust the re-ranker versus the cheap retriever. If you push the weight toward the re-ranker, you get more aggressive reshuffling. If you favor the retriever, you keep conservative orderings. The final effect is a compact and stronger top 3 that balances speed and accuracy. Mapping to a real system is straightforward. Replace the token overlap retriever with a fast approximate nearest neighbor index. Keep the re-ranker as the slow second stage, and collect a few hundred labels to move from toy to useful. Measure latency and top K accuracy as you grow the candidate pool. Recap: what it is: a 2-stage re-ranking pipeline that inspects query document pairs with cross-encoder style features. When to use it? When your retriever finds reasonable documents but misses the best answer in the top results. One caveat: the re-ranker adds compute and needs labeled signals or careful tuning to avoid overfitting. Next step: scale this exact approach by replacing the initial retriever with an ANN index and add timing and accuracy checks so you can tune candidate pool size and the blend weight with real metrics. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.